Example, P is in bracket 60 north, 15 degrees east. Q in bracket 60 degrees north, 48 degrees west, and R is in bracket at 5 degrees south, 48 degrees west. Three places on the Earth's surface. Assuming the Earth to be a sphere of radius 6,400 kilometers and taking pi as 22/7. Calculate correct to three significant figure. A. The radius of the latitude of R. B. The distance PQ measured along the parallel of latitude. C. The distance QR on the surface of the Earth. D. The time taken by an aircraft to fly from P to Q and then Q to R if the average speed is 80 km/h. Solution. Our P is located in bracket 60 degrees north, 15 degrees east. Our Q is in bracket 60 degrees north, 48 degrees west. And our R is in bracket at 5 degrees south, 48 degrees west. Then we draw out the lines of longitude along the vertical axis of the lines in the circle, and our latitude along the horizontal lines of the circles in the circle. Then we now have that our P, we locate our P by measuring 60 degrees from the equator, then locating 15 degrees along the latitude. We then mark the P. We now have the location of the point P. For Q, we measure out 60 degrees north, and since it's now 48 degrees west, we locate 48 degrees west along the latitude. We mark our 48 degrees west. Then for R, we measure out, since it's now south, we measure out 35 degrees south downwards. Then 48 degrees west, we now locate the latitude along the small circle west. Then we now have that our A is equals to the radius, small radius is equals to big radius, which is the radius of the S cos 60. Therefore, R is equals to 6,400 cos 35, which gives us 6,400 times 0.7880, which gives us 5,043. For the radius is equals to therefore A, we are asked to calculate the radius of the latitude of R, which is 5,040 kilometers to the nearest significant figure. Therefore, we now have that. Still working on the solution B, the distance PQ measured along the parallel line of latitude. We have the formula theta over 360 times 2 pi r cos theta phi. Therefore, our theta is equal, since they have different, we now have that we have 15 plus 48, which is equal to 63. But from the formula, from the question, we have that phi is equal to 60 degrees. Then we now have 63 over 360 times 2 times 22/7 times 6,400 cos phi, which gives us 3,520 kilometers. Then the last question, the next question is the distance QR on the surface of the Earth. We still have the formula theta over 360 times 2 pi r. We substitute the value, we have that our theta to be 98 over 360 times 2 times 22/7 times 6,400, which we now have that 98 times 44 times 6,400 all over 2,520, which gives us 10,951.1, which is the nearest significant figure. It is 11,000 kilometers. Then the last question said that the time taken by an aircraft to fly from P to Q and then from Q to R if the average speed is 800 km per hour. Since we have known that this formula for speed is equal to distance over time, therefore we make time the subject of the formula, which we now have time equals to distance over speed. When you substitute the value of distance, we now have that 10,951 plus 3,520 all over 800, which will now give us 18 hours, 18.1 hours. 24. P is located in bracket 38.6 degrees north, 28.7 degrees east, and Q in bracket 38.6 degrees north, 21.3 degrees west are two places on the earth's surface. Another place, T, is on the same meridian as P, and its latitude is 294 degrees north. Assuming Earth is to be a sphere of radius 600 kilometers and taking pi as 22/7, calculate the A, the radius of latitude of P and Q, B, the distance PQ, C, the distance PR, D, the total time of the journey if the aircraft covers 650 km per hour. Solution. Our P is 38.6 degrees north, 28.7 degrees east. Our Q is in bracket 38.6 degrees north, 21.3 degrees west. Our W is in bracket 29.4 degrees north, 28.7 degrees east. Then we find our radius latitude, which is R equals to big R cos theta. Therefore, the radius of the latitude is equals to 6,400 cos 38.6, which is equals to 6,400 times 0.7815, which gives us 5,001.6 kilograms. Therefore, we draw our geometry knowing that our latitude is on the vertical axis of the circle and our latitude is on the horizontal axis of the sphere. Then for P, we measure out 38.6 degrees north with our protractor and use a ruler to join it out to the point P of latitude 28.7 degrees east. Then for Q, we measure out 8.6 degrees with our protractor from the equator. Then use our ruler, since it is at the west part of the sphere, we now locate 21.3 degrees west at the west. Then for W, we measure out 29.4 degrees north and locate it at a 28.7 degrees east, since P and Q have the same latitude. To calculate the distance PQ, we use the formula theta over 360 times 2 pi r big R cos phi. Theta is equals to 28.7 plus 21.3, which gives us 50 degrees. Phi is 38.6